in looking for Pythagoras investigation 4 problem 4.4, we're going to now apply the rules for a 30, 60, 90 triangle to this shape and use those rules to find all the side lengths and then use those to find the area of this. So if you look at this triangle, there's actually 3 triangles. There's this little one here, and then this bigger one here, and then the entire thing is triangle number 3. And the only thing we have so far is from A to D is 8, but that's all we need, because if we know is A to D is 8, and this is a 30, 60, 90 triangle, we know that this distance over here has to be twice as much, or 16. And that's just using the rules of 30, 60, 90 triangles to do that. We also know that from C to D is this base leg length 8 times the square root of 3. Now, I'm going to rotate this because I want to think of another 30, 60, 90 triangle, which is this one. Here's 60, 30 up here, and this corner is actually a 90-degree angle. And this now is actually the base of that larger, the big, giant triangle. And so that allows me to find this length right here, all the way across, because now, again, I'm looking at half of a equilateral triangle, and if this is 16, then the full length has to be 32, or twice as much, from A to B. And then from C to B, this 16 down here, I'm going to flip it over so it's not upside down. That's 16 length here. Gives me the length of CB using the rules of 30, 60, 90 triangles as 16 times the square root of 3. And so now I actually have all 3 sides of this triangle. And the only length I don't have right now is from B to D, but that one's easy to find, because if this section from here to here is 8, then the rest of the way from D to B has to be the difference between 8 and 32, which is 24. So now I do have all of the different lengths, and I can use those numbers to find the perimeter. And so if I want to find the perimeter, I need the distance around the outside, so I need the A to B, which is 32, and then B to C, which is 16 times the square root of 3. And whenever we have answers as square root numbers, and we need to actually do the calculation part of them, we need to actually find a solution. We want to calculate that out. So if I calculate 16 times the square root of 3, that actually comes out to 27.7 approximately, and we'll go to 1 decimal point just to give us enough information on that. And then from C to D, or C back to A, excuse me, is the other 16 up here. And so if we can put those numbers together, because perimeter is distance around the outside, so A to B to C back to A again. So 32 plus 27.7 plus 16 gives me a total distance of 75.7 units for the perimeter of that shape. And if I didn't have the 30, 60, 90 triangle rules, I would have had a very difficult time figuring that out. But using those rules helps with that. Now the area of this triangle, ABC, this full triangle, to find the area of a triangle, we take the base times the height and divide that by 2. That's how we find the area of triangles. And so we know the base of this triangle is 32, and the height is 8 square roots of 3. And we're going to have to take all of that and then divide it by 2. But we need to get this 8 square roots of 3 into an actual number. It approximates out to about 13.9. And so then we put that together and we get 443.4 divided by 2. And that comes out to 221.7 units square, because it's area now. So we're talking about area, and so we have units squared for area. So again, base times height divided by 2, base times height. This is the base times the height of the triangle. It's this tall, it's this long across. That gives me the area of that triangle. And if I want to now find the area of the smaller triangles, triangles 1 and 2, I need to do the same thing. Base times height divided by 2, and then base, this one's base is 24, times height divided by 2. So I do those calculations of the first one. So of ACD, this one, I have the 8, the base, times the height, 8 square roots of 3, divided by 2, and that comes out to 55.4 units squared. And if I do the other one, base times height divided by 2, I get 166.3 units squared for the area of that triangle. And one good check in this problem is these two smaller triangles, areas, these two smaller, this one, number 1 and number 2, should add up to the area of the larger triangle. So if you look at 166.3 and 55.4, and they do add up to 221.7 units square for the whole triangle. So that gives us the full, all three triangles areas, the perimeter on the outside. We actually know all of the side lengths, and all of this using the concept of the 30, 60, 90 triangle, which we've done in previous lessons, but just a reminder here that if I know this is a 30, 60, 90 triangle, and I have this length, we call it x, this is twice as much, and this is whatever x is times the square root of 3. So we've used that rule to solve this problem with 30, 60, 90 triangles. It's a special triangle, and it always follows this rule, and so we can use that rule to help us solve it. And so that's problem 4.4.